As we saw in the last lesson, if we want a runtime exception on overflow, instead of values wrapping around, we can make use of the Math.xxxExact methods introduced in Java 8. If we type Math.addExact and tab twice, we can see that there are two overridden methods, one returning an int and the other a long. Now what if we want to use the byte or short but want an exception at runtime on overflow? Welcome to lesson 30 part 4. I set JShell feedback mode to verbose so that we can get the most verbose feedback. Note that we pass two byte variables to the addExact method, and Java made use of the addExact method that takes two ints and returns an int. So we passed it the 2 bytes and we know that they fit in an int, so that's okay. See, JShell provided a scratch variable of type int as we did not declare one. Now the issue is that it returns an int with a value of 128, and we know that that is greater than our max value, and we wanted an exception at overflow. So we cannot make use of the addExact method for our purpose, as it does not throw an exception when the byte overflows. Now if you look at the documentation, you can see that if you look at, say, the addExact and the two parameters, the int x and int y, you can see the first parameter that it takes is an int and the second parameter takes a y. Then you add the two and the result that's returned is also an int. And it says here an arithmetic exception if the result overflows as an int. So if you look at the figure here, but I want when it wraps around, if you can see these arrows here, when the value is bigger than a byte, and we're passing a byte to an int, and obviously it will never wrap around, as you can see here, because we're passing it a byte. It's converted to an int, and an int is much bigger than your byte value, so it won't throw an overflow on a byte overflow because it's been converted to an int. So what we're going to do in this case, so what we can do is we create our own method. As you can see on the sketch on the right, the blue, the negative 28 and the positive 127, that's the range of your byte. And you know when it goes over that, it will overflow. Now we know that when an int is larger or smaller than the allowable byte, we have to cast it, and there can be a loss in conversion. In other words, it overflows, as I'm showing there in the red block. When we take an int and we cast it to a byte and that int is too big, it will wrap around, so an overflow has occurred. So that's what I'm doing in this method here. I'm creating a static method that returns a byte, and I'm also naming it addExact, and instead of taking ints, it will take 2 byte variables of x and y. And then inside it, we know that when we do an addition by default, it will change it to a byte. So the x, which is a byte, I mean, it will change it to an int. So there I'm saying R1, which will return an int. Its operation is the x value plus the y value. What I'm doing in the next one, I'm taking that result, which is an int, that x and y will result in an int, and that R1, I'm casting it back to a byte and variable R2. Now, what I'm saying there is if R1, because if it's greater than R1 will be greater than allowable values, if it's an int, which is fine. So if I had to take 128 plus 127 plus 1, it will be a 128 in R1. But if I cast it, it's going to overflow or underflow on R2. So what I'm saying there, if R1 is not equal to R2, then it's wrapped around and overflows occurred, so then it must throw in a runtime exception with a comment overflow occurred. Otherwise it didn't occur, it will just return the byte to me. Now in the following we do some tests to test our method. I'm calling addExact, and I'm taking a value of 12 and 100 of type byte. I'm casting them to bytes, and it's giving me 112, and as we can see, it's well within the range of negative 128 to 127, which is the range of the byte. So it gives me 112. The next one, I'm taking 126 byte and 1, which gives me 127. That is right in the edge case. 127, that's fine. The result is 127. You can see scratch variable 7 there. And then I'm adding 126 plus 2, which gives me 128, which is now going into the int range, or the short, bigger than byte anyway. And it's giving me an overflow exception, runtime exception, like I asked my method to do. And then the next one, you can see I'm testing with a negative. I'm taking a negative 126 plus 2, a negative 2, which gives me a negative 128, which is in the border, which is on the border of your byte range. Negative 128 is your minimum value, and that's fine. Scratch variable 9 gives me negative 128, and when I go over it on the next one, which is negative 126 plus negative 3, it's giving me overflow runtime exception. So our method is working like it's supposed to. We have reached the end of this lesson. We saw that if we want to use a byte and have the JVM throw a runtime exception when an overflow occurs, then we need to write our own method for that purpose. We did that by writing our own addExact method that takes 2 bytes as a parameters and returns a byte. We can do the same for the other exact methods, such as the subtractExact or the multiplyExact. The same would also apply for the short data type. I hope you've enjoyed this lesson, learned something from it, and please don't forget to press the subscribe and notify button. I've also got a Facebook page related to this channel. You are welcome to join my adventure channel, where I share photos and videos of various activities. Until we meet again in our next lesson, I wish you well and happy coding.